Okay, this week we're talking about Chapter 12. So, separate compilation and namespaces. If you recall, we've talked before about abstract data types in which we have separated the interface and the implementation of the class. We want all of our class definitions to be ADTs, and there are some rules for doing that on page 687. Make all of the member variables private. Make each of the basic functions for the class either a public member function, a friend function, an ordinary function, or an overloaded operator. And we group the class definition and function and the operator declarations together. That goes in the interface with appropriate comments about how it works. And then we make the implementation as a separate thing, because the function definitions and the overloaded operator definitions, along with any helping functions and any etc. we have, so that those are not available to the programmer that's using our class. They only get the part that's in the interface. So, our first example is in display 12.1, the interface for a class called Digital Time. This would be all that a programmer using the Digital Time class would have access to. So you'll see the declaration of the equal to operator, the declaration of a couple of constructors, and we've got the advance, or a couple of overloaded advance functions, the overloaded extraction operator and insertion operator, and then the two private member variables, hour and minute. Okay, that would be the include file, the dtime.h file that they would put in their program in order to use the Digital Time class. In 12.2 we have the implementation file for the Digital Time, which includes the dtime.h, so that would be the declaration, and that has the details of how those previously defined functions work, plus some additional functions that the programmer decided they needed that aren't technically part of the Digital Time class, but the programmer wanted to use. And what we would then do is compile the digital time implementation to an object, and then someone wanting to use it would refer to it with the dtime.h, declare a digital time variable, and as long as they had the object file, the previously compiled object file, available to the linker, it would be able to include that code in their program. Another thing they go into in this chapter is the if-n-def macro, page 697, $ifndef. This is a way for us to be able to include multiple files in our program and not have them accidentally be declared multiple times in one single program. So basically we have the define as shown in display 12.4 that tells us we have included this digital time in our class, in our program, and preceding that we have if not defined digital time. So if it's not defined, we're going to define it, and then in that section will be left out if it's already been defined previously in our program. So if our program, for example, includes multiple references to the digital time class, we make sure it's only defined once.
So where it says the definition is the same as in 12.1,
right,
we would put all of that in there, and then we would put the end if
yeah.
at the end of that.
So basically what it would do is after the if, ndef, and the define, we would have everything that's in 12.1, and then we would have the end if at the end. Alright, so that brings us back to namespaces again also. Once we start defining our own classes that we want to be widely used, it's going to make sense for us to care about how we're naming those. So theoretically, two different programmers could have a class called digital time, for example. Well, in order to make sure that those don't collide with each other, we can define them in our own namespace. So far, all of the stuff that we've been using defined in a particular namespace has been using the std namespace. So that's one example of a namespace we could use. But if we wanted to define our own CIN and COUT, it might make sense not to use the namespace std so that we could have our separately defined as CIN and COUT. Everything that we write is going to go into some namespace. If you don't specifically tell it the name of the namespace you want to use, then we're using what's called the global namespace. Okay, so everything that we wrote in the first semester of C++, everything we've written up to this point has been in the global namespace because we had not defined any other namespace. On page 703, you see what would happen if you have two different namespaces, each of which have a function called myFunction. In order to call one of them, we would put that call in a scope that's in the namespace ns1. We would put the other one, that's function call, in a scope for namespace ns2.
So, if both of these functions were defined in just one namespace, it would not be legal.
Right. They would have, you would have a naming collision, and it wouldn't compile. Your program would not compile because it would not know which of those functions you were referring to.
Okay.
Well, yeah, if they were, you couldn't define them both in the same namespace. So if you had files in your program that tried to put them both in the same namespace, that's where you get the name collision. That would be just like you putting two functions in your program with the same name and the same signature. It would say, well, those two functions are incompatible with each other, and I don't know how to compile that, so it's a syntax error. So, in order to put your code in its own namespace, there's a new syntax we're going to learn, and that is in 12.5. So here we have two namespaces, Savage1 and Savage2. They both have a call to, they both have a declaration of a greeting function. Then at the end of the program, in namespace Savage1, we have the definition of greeting, and in namespace Savage2, we have the definition of greeting. So those are two different functions in different namespaces. And big greeting is also in a namespace, but what namespace would it be in?
Global.
In the global namespace, right. Alright, so in order to call those, we have to issue a using namespace so that they are in, those calls are made in unique namespaces, which gives the context for the compiler to understand where they're coming from. So first one is going to be in using namespace savage2, so we'll get greetings from namespace savage2, and the second one will be in namespace savage1, so we'll get greetings from namespace savage1, and then when we call big greeting, we'll get the one that's in the global namespace.
So we have to define the namespace and
okay, I seem to have lost you. Just getting a tapping noise. I'll go ahead and try to explain this. We have to define the namespace that we're going to declare these in with the namespace keyword that goes around the block of code that we're defining them in. Likewise for the declaration. And then when we're ready to use them, we use the using namespace directive. Now, sometimes you're going to want to be able to use multiple things that are defined in multiple places, and it would be awkward to use a block of code and a using namespace declaration for each one of them. We can specifically declare particular things to be in particular namespaces without having to make all the names in the namespace available. So as long as we don't have a namespace collision, so for example, if we change this to greeting1 and greeting2, the fact that they're in different namespaces would not be a big problem. We would just put in a declaration using savage. Oops, I did that wrong. Greeting2, greeting1. Using savage1, greeting1. Using savage2, greeting2. That would allow us to use just that one identifier from that namespace without having to open up all of that namespace for us to use anywhere. Then we could just simply call greeting2 and greeting1 and it would correctly find them for us. And you've seen this double colon already. That's the scope resolution operator. Another thing we could do, so if we go back to the way these were defined before, so we have a greeting in Savage 1 and a greeting in Savage 2. Instead of making a whole block of code, since we're only using this once, we could just call it this way. That would be exactly the same as doing it in a block of code like that. And we could use this to overcome the limitation that we had before, if you recall, of having to declare our namespace at the beginning if we were using something from it in a function call. For example, iStream. Instead of declaring it at the beginning and making it declared for the whole program, we could, now that we know how to do this, just say std iStream and std oStream. And that saves us from having to put that using namespace std at the beginning of our program that we didn't want to have to do. If you're going to be using that syntax, the using std as opposed to this one where you fine-tune it for every single usage. If you're going to use instead using Savage 2 greeting, you should be aware that you only get that one particular name in your code. So if we said using, for example, using std cout, well, we could use cout, but we would not be able to use cin. And they make some other fine points about using the different syntaxes. Probably the best advice I can give you is to, be careful about your namespaces first of all, but if you're only using something a very limited number of times and you don't want to have to worry about how the namespace is defined, you can always strictly identify it by using the namespace with the scope resolution operator right in front of your identifier. All right, Matt, that makes sense? Okay,
Yep.
good. Now, display 12.6 shows us how to put our class in its own namespace. So in the digital time class here, we now have that declared in the dtime savage namespace, and they've left out a lot, all of the code here. In 12.7, they have put part of the code in a namespace that they have not supplied a name for, and that's called the unnamed namespace. Okay, so another namespace, it's not the global namespace, it's the unnamed namespace. And anything in the unnamed namespace can only be referred to in the unit it's compiled in. So if we compiled the implementation of our class, in this case, only the code in the implementation of our class would be able to refer to these special functions read hour, read minute, and digit to int. So any program that we compiled, to use the class with the interface file for the class, and that included the class object that was compiled separately, would not be able to access read hour, read minute, or digit to int. There's no namespace that you can define, no way for you to refer to that. It's been put in the unnamed namespace. And then 12.8 has a demonstration of what we just talked about, hiding the helping functions in the unnamed namespace. And we've declared a read hour function in this program. It will not conflict with the read hour in the digital time files, because that one is in an unnamed namespace that we don't have access to from a separate program. So now you get to figure out how to make your abstract data type. Let's look at today's assignment. That will be assignment 6, chapter 12, number 1. You're going to take this digital time class that we've been looking at in the chapter. And you're going to add a new member function called interval sense. Interval sense, you see on page 718. It's going to take as one parameter an existing digital time, a number of hours, and a number of minutes, and it will compute the time interval between the object that calls it and the other digital time object that it's being compared to, and return the difference in the hours and minutes parameters. And this shouldn't be too difficult. You've been given most of the definition of the digital time class. The only tricky part will be if the first argument is later in the day than the calling object. So in other words, I've got an object with a time of day of 12 o'clock, for example, noon. Or let's say 1 o'clock, make it a little simpler. 1 o'clock, and the argument I'm passing to it has a time in it of 2:30. That would be the previous time. Then we assume that the 2:30 is from the previous day. And I believe this is set up, yeah, the time is in 24-hour notation. So that would be the difference between 2:30 one day, 2:30 a.m. one day, and 1 a.m. the following day. So, are there any questions about that?
Do we have to, so it should be like an ADT like the other one? So do you want it all in separate files or whatever?
Right. You should make an let's see, you should make an interface file that you include with your source code file, and an implementation file that you compile separately. And so let me see if it says, well, there's so your test program is going to demonstrate how it works, but it should be in separate files. So you should compile the implementation separately from your test program, and if you have any trouble doing that, contact me and I'll see if I can get it straightened out.
But this is basically going to be based off the digital time that's already in there?
Yes, basically
Okay.
you're going to take the digital time that's already there and you're going to add the interval sense function to it and compile digital time as its own object and then use an include to make a digital time variable in your test function that you can then use to measure the time difference. And what I would like you to do is allow the user to enter two times a day and in your test program. All right, does that make sense?
Mm-hmm.
Okay. Any questions about that assignment or your previous assignment?
I think I was actually like on the last one. It's like I couldn't remember when we overload. Basically, like overloading the urinary operators. This is basically like almost the same as how they do it with the money
Yes.
part, I think.
Right.
Except, I'm sorry. Except we need to do it for both variables, don't we? We need it for the f variable and the s variable.
Well, the unary operator that we're talking about for that one is the minus, is that right? Is that the only unary operator?
I think there's plus and minus, I believe.
Let me take a look at that assignment. Okay, so standard, plus and minus, add, subtract, and multiply, those are all binary operators.
Yeah, I guess basically those are the ones I was talking about.
11. Alright, so number 2. You overloaded the extraction and insertion default constructors with 1 and 2 parameters. The binary plus operator and the binary minus operator and the asterisk operator. So I don't think you were asked to do any unary operators. exercise 17. Let me look up exercise 17 real quick to make sure I'm not telling you wrong. So here's the class pairs. Implement extraction, insertion. Yeah, you don't, there's not a requirement for unary operators.
Well, yeah, I guess I was just talking about the plus and minus operators.
All right, well, definitely those both can be. Okay, on page 637 you have the money class declaration, and it does in fact have a plus binary operator and a minus binary operator and a minus unary operator, and that makes sense for money, making it negative rather than positive.
Yeah.
But that's not required for the pairs class. All right?
But when we do it, it's basically like the same method as they use for the money class.
I would say if you were implementing a minus operator, unary operator on a pairs, you would apply the minus to both members of the pair. Does that make sense? You're just negating that entire pair.
But as far as it's like overloading like the plus sign,
yeah,
you know, or adding them or whatnot,
right,
you would just basically do it basically just how they use with the money class.
Yeah, it's very similar.
You have to create a temporary variable.
Temporary object of the appropriate type.
Okay.
Yeah, that's right.
All right, yeah, that's pretty much all I was kind of wanting to know.
Okay, very good. Any other questions?
Nope, that was all.
All right. Well, I guess that is the end of our video conference for today. And like I said, if you have any questions, contact me either by email or on Google+, and I'll try to answer your questions. And I'll see you next week.
All right. We'll see you then.
All right. Thanks. Bye.